Hey there, geometry students. It's great to see you and be seen by you. We're on 5.8, our last section for chapter 5. Notice it is 5.8, so we're skipping 5.6 and 5.7. Just didn't think it was necessary or as important as covering this section. You're going to find what we cover in this section to be very, very useful in your future math careers and actually to prove kind of useful generally. If you want to cover 5.6, 5.7 on your own, you're definitely welcome to do that. So let's jump right in. 5.8, special right triangles. We have two definitions, which are basically two right triangles, and you're going to see what we're covering here as we define these. And basically what that is, so when we see 45, 45, 90 triangle, that is a special right triangle that has those angle measurements. Actually, no, I'm going to draw that more over here, where again, it's a right triangle, so you have the 90, and then the other two angles are 45 and 45, okay? And so what we mean by a special triangle is that when it comes to the sides of a special triangle, they have a specific ratio to the point that if you know one side of the triangle, one side length, and you know that you have a 45, 45, 90 triangle, then you can know the other two sides of the triangle. So for example, in a 45, 45, 90, you know that the legs, let's just say if one of the legs is x, you can therefore express the other two leg distances of the other two legs, or the other two sides, the leg and the hypotenuse. So one thing you can notice is since both angles are the same degree, 45, 45, you can kind of apply what we looked at in 5.5, that there's a relationship between angles and sides, or even what you know about isosceles triangles, that since you have two equal angles, you must have two equal sides, and that's the case here. If that one leg is x, then I know that the other leg also has to be x. So you can immediately know both legs. Then in terms of the hypotenuse, there's just a ratio that you memorize, and that is if you take that number x and multiply it by the square root of 2, that's the length of the hypotenuse. So in a 45, 45, 90 triangle, if you know it's that type of triangle, then you immediately know the two legs are the same number, and the hypotenuse is that number times the square root of 2. So as just a simple example, if we take another little triangle here, and they tell us, okay, so this leg is 3, and of course they tell us this is a 45, 45 triangle. So then I can immediately say, okay, well, I know what the other leg is, and I know what the hypotenuse is. The other leg must be 3, and the hypotenuse must be 3 square root 2, because I just take that x and put it in front of the square root of 2. You can put that in a calculator and find that out as an actual decimal, but in this chapter we'll be expressing it with the radical or with the square root as part of the answer. So you just simply have 3 square root 2. Okay, again, I could do lots of other examples, but you'll be practicing that later on. Just know the two legs are the same, and the hypotenuse is that leg distance times the square root of 2. So then when we get to our other type of special triangle, a 30, 60, 90, we have a similar situation. The numbers are going to be different, but it's the same idea that if you know one leg, you can then calculate, or even just one side, you can calculate all the others. The important thing to point out here is you have a smaller degree 30, and you have a larger degree 60, and then you have, of course, the 90-degree right angle. It is important. The 30 degree will always go with the longer, narrower angle, and the 60 is always corresponds to what we call the shorter. So unlike the 45, 45, where it doesn't really matter, the two legs are the same, with this one, you do want to differentiate between your, let me write it right here, your long leg here and your shorter leg right there. Okay, but the ratio here is if you know your short leg to be x, then what you know is that your hypotenuse is always twice as big. So it's 2x. And then you know that your long leg is that same number x times, in this case, the square root of 3. And again, that kind of just might seem arbitrary, but again, just start to memorize it and apply it. You'll just realize it as kind of a formula. And so then again, knowing any of these one sides, you can calculate the other two. As a very basic example, let's draw another one of these. Actually, let me draw it this way, just to kind of show you. So say we put it on its side like this. Again, the narrower angle would have to be your 30 degrees. Your longer angle would have to be your 60 degrees right here. Okay, so if I knew that the short leg was 5, then I would know, and notice that's the short leg, even though I kind of knocked it on its back there. The hypotenuse would be twice as big at 10, and the long leg would be that same short leg in front of the square root of 3. So that would be 5 square root 3. Okay? And so therefore, same idea, but you're just going to want to memorize both of these, that x square root 2 and then x and x for 45, 45. And for 30, 60, you've got the short leg as your x, your hypotenuse is twice as long, and then your long leg is x square root 3. Okay? So let's go ahead and move on to the questions and apply some of this. And trust me, when we get to a trig, anyway, it's going to be very, very useful to have these memorized and be able to solve these triangle distances quickly. It's super valuable later in this, in geometry. It's extremely valuable in Algebra 2. And if you continue into pre-calculus, where you do trigonometry or even into calculus, you're going to want to know these ratios. They're going to be very, very useful. I'm not trying to waste your time with this one. Okay, so let's see. We got some questions here. Looks like I accidentally hid the questions from myself. Let me pull those out. There we go. All right. So the first question is, if you know a triangle is 45, 45, 90 or a 30, 60, 90, what method do you not have to use to find the missing sides? Okay, so what this question is getting at is we've actually already learned a way of solving right triangles, and that is the Pythagorean theorem, where we would have a squared plus b squared equals c squared. And so what I'm trying to get at with this question is you no longer need the Pythagorean theorem if you're dealing with a 45, 45, 90, or a 30, 60, 90. Okay, and I just want to show you with one of these how using the Pythagorean theorem actually gives you the ratios that we've talked about. So for example, let's go ahead and I'm going to change this right here. And let's just say that this is in fact x. And this is in fact x. Let's go ahead and use the Pythagorean theorem and solve for the hypotenuse. And so that would be x squared plus x squared equals c squared. All right, so then that simplifies to 2x squared equals c squared. Okay, and then we would divide by 2. Actually, sorry about that. I'm going to just move all this up here really quickly. X squared plus x squared equals c squared, because I plugged in my legs. Then we've got 2x squared equals c squared. And now I'm going to divide both sides by 2, because we're trying to solve for x. Well, actually, we're trying to solve for, apologies, we're trying to solve for c. I want to show you c. So to get c by itself, now I would just simply take the square root of both sides. Square root, square root. So on the right side, I get c equals the square root of x squared is simply just x. And the square root, because you're kind of taking the square root of both of these right here, the square root of 2 is the square root of 2. And so you can see right there that the hypotenuse is x square root 2. And so rather than if I knew, say again, if I knew that this side was 5 and I knew that this side was 5, rather than go through that whole process, 5 squared plus 5 squared equals 25 plus 25, square root of 50, take the square root, on and on and on. Now that you know the shortcut, I can go, oh, 5, the other side's 5, and the hypotenuse is simply 5 square root 2. Okay, so it's very, very, very fast. I'm not going to go through the whole process with the 30, 60, 90, but just to refresh, if I knew the short leg was 7, I know the hypotenuse must be twice as big, 14, and then I knew the long leg must be the same as the short leg times the square root of 3. And if you go ahead and plug in the Pythagorean theorem there on with those measurements, you'd see that it works out. In fact, well, let's just go ahead and do it. No, we'll skip it. Well, you can ask me to do that in class if you'd like. So let's move on to question number 2. So anyway, for number 1, the idea is you don't have to do, I should write my final answer, you don't need the Pythagorean theorem. Use the shortcut. This is in fact a shortcut. And it's a shortcut for lots of things. So again, I encourage you, it's very worth your while to learn it. All right, number 2, second question is, if a 45, 45, 90 triangle has a side length of 7 centimeters, what is the other side in the hypotenuse? You can see these questions are going to go lightning quick because it's very easy. 45, 45, the side legs are the same. So if that's 7, this must also be 7. And since there's units, I'll add that, 7 centimeters. And then the hypotenuse is that number in front of the square root of 2. So again, rather than use Pythagoras, I can just do that. And again, who doesn't like being done really fast? It's a wonderful thing. And being right at the same time. Okay, and we have the same thing, 30, 60, 90. If you have the, what does it say? The short leg is 2 centimeters. What are the other two sides? Oh my goodness, it's going to take us the blink of an eye. The hypotenuse is twice as long. So that must be, whoops, not 6, 4 centimeters. And the long leg must be that short leg, 2, in front of the square root of 3. And we're done, centimeters. The one kind of warning I'll make about the 30, 60, 90 triangle is a lot of times people just, because the square root for the 45 is on the hypotenuse, they associate this square root of 3 with the hypotenuse, and sometimes they'll double it for the longer leg. Just break yourself of that habit. That's not how it works. The radical 3 goes with the long leg, and the hypotenuse is twice as big as the short leg. Okay, so number 4. This is where things will get a little more interesting. But again, if you can do this, you're golden. Number 4 says, what if you know the hypotenuse first? How then are you going to find the short sides? Because notice, I've been giving you the nice side. I gave you the legs for the 45, and I gave you the short side for the 30-60. What happens if you already know the hypotenuse? What would you divide by to get the legs? And so if I just want to show you a very basic technique that once you catch on, what I consider the harder problems of this lesson will not be that hard. So here's what we would do. So say I knew the hypotenuse was x. I don't want to say the answer is x. This is the mistake you could make. Oh, it's x root 2. No, because that's wrong. No, the leg is x, and the hypotenuse is x root 2. So what if they start you off with the hypotenuse? Well, here's how I would consider it, and then you'll be able to do it really quickly. We know that the hypotenuse is x is equal to x square root 2. So how would I get that x by itself? What would I need to do with that square root of 2? Well, I would simply need to divide by the square root of 2. And that would cancel out. So in other words, the leg, if I already know the hypotenuse, then my leg is equal to x over the square root of 2. And in this case, both legs are still the same. So this would also be x over the square root of 2. So the question 4 asks, what should you divide by? If you already know the hypotenuse, you want to divide by the square root of 2 instead of multiplying, because you're kind of going in the opposite direction from hypotenuse to leg. Okay? And so similar question for the 30-60, what are you going to do if you already know the long leg and you don't know the short leg? So again, it's kind of going in reverse. You would not want to say x square root 3, because no, that's not correct. That's the wrong order. But same idea. If I would normally multiply by the square root of 3, but I already know that long leg, then I'm going to I know that this is equal to x square root of 3. So you can see I would solve for that by dividing by the square root of 3. Okay, so my short leg would be x divided by the square root of 3. And then for my hypotenuse, I would simply double that, which just means 2 times. So that means it would just be 2x over the square root of 3. And there we have it. And we can simplify radicals, but we'll talk about that in class when it's necessary. But for this point, again, if they give you that, and we're going to practice this in our last question before we're done, if they give you the what I call the radical side, the hypotenuse, again, going all the way to our notes, if they give you the square root of 2 hypotenuse, or they give you the long leg x square root 3, simply divide by that radical, and you'll have your missing sides. And a 45, 45, 90, divide by the square root of 2, and a 30, 60, 90, divide by the square root of 3. And so let's practice that before we end this. So say you have these are 2 problems from the book, and they give you the hypotenuse, 12. But you don't know the legs. You can see they're both the same. They're both x and x. but how do you find that? Okay. Again, the mistake that you could fall into is you go, oh, it's just 12 square root 2. No. If that was the leg was 12, and the hypotenuse would be 12 root 2, and that'd be correct. But this is the hypotenuse already being 12. So let me show you it slow, and then of course you can do this really fast once you understand what's happening. We know that that 12 is equal to the x square root 2 side, right? Because the hypotenuse is the x square root 2 side, and the legs are the x's. So I would just then, to solve for x, I'm just going to divide by the square root of 2. That's what we just said on problem number 4. And so we can see that x, or the legs, must be equal to 12 over the square root of 2. Okay? X divided by the square root of 2. And they're the same, so I know this is 12 over root 2. And I know that this side is 12 over root 2. In class, we're going to talk about how to simplify that denominator, because you actually can't. You'll see if you look for this answer in the book, it probably wouldn't be there, because there's a rule about simplifying square roots at the bottom of fractions, and you can't do that. But for now, those are our answers: 12 over the square root of 2, 12 over the square root of 2. Notice we did just what we said number 4. We took the hypotenuse divided by root 2. So now let's do the same thing with a 30, 60, 90. The long leg, they've given it to us, is 15. We're going to divide by that radical since we've got the radical side. This is equal to x square root 3. So we're going to divide both sides by square root of 3. And so we have here x equals 15 over the square root of 3. So that means that's what this side is. Just that number over the square root of 3. And then when I want my hypotenuse, I just double that. Double the short leg. Not 15. It's not 30, but it's 2 times 15 over square root 3, which is just simply 30 over the square root of 3. And again, we've got a square root in the denominator, and so we'll need to simplify that, but we'll cover that in class. So, and maybe I'll make a video on it so you have it as a resource, because it is a useful skill you'll need. But again, finding the sides lengths of special right triangles, you can do it very, very quickly. And these last two problems focused on, you can do it very, very quickly, even when they give you kind of the tricky radical side. All right, I'm going to end this video now, but if you have questions, let's hammer it in class and have a good time, and we'll be wrapping up chapter 5 and bringing this to a close. Though again, these special triangles will be very, very useful routinely moving forward. All right, see you soon in class.